Hello, everyone. We're coming back to you today with graphing one more polynomial function to make sure we got this down. So in this one, we're being asked to graph this polynomial. And the first thing you want to think about is, can you predict the degree and the leading coefficient of this thing? So the way you're going to do that is you're going to look at it and you're going to say, okay, if I'm finding the degree, the only thing that matters is the highest degree in each factor. So in this one's really x, this one's really x, this one's really x. So as we multiply this all out, you're going to expand this out into a lot of algebra, which thankfully we don't have to do in this problem. But in your head, you can think about multiplying this all out. That's where the highest degree is going to come from. So when we multiply out this first one, there's going to be an x squared that comes out as the highest due to the fact that we're FOILing this out. In the second one, we're going to end up with an x cubed, again, due to the fact that we would be multiplying x plus 5 times itself for a total of 3 factors. And this last one, we're going to end up with just x to the first because there's no exponent here, so it's just going to be x. Now, before you think you're done, what you need to remember as well is that there is a factor in the front, and that would get multiplied by the leading coefficient. So in finding the greatest term, the degree term in this one, it's going to be -1 times x squared times x to the third times x, which is really going to say that this guy has kind of the basic characteristics of a -x to the sixth. Now keep that in mind because we're going to use that fact when we get down to the end behavior. So from here, we're just going to follow our steps. We're going to find the x-intercepts first. So the x-intercepts are going to be found when we set this function equal to 0. If I take that function and I set it equal to 0, what I'm really doing is I'm setting each factor equal to 0. So as we go through this, we can just have to go by factor and find out where those will equal 0. So in the first case, +3 will make that factor equal to 0. In the second case will be -5. And the last one will be x equals +5. Now, it's a good time for us to talk about multiplicity. Remember, if we have repeated factors, the multiplicity is going to affect how this graph interacts with the x-axis. In this first one, we have a multiplicity of 2, and that's even. Keep that in mind. In the next one, a multiplicity of 3, and the last one, a multiplicity of 1. And again, we're getting that because of the number of repeated factors. This is a square, 2 repeated factors, cube, 3 repeated, and this one's just a first power. Anytime the multiplicity is even, we're going to have a bounce on the x-axis. So this is going to tell us that we're going to bounce. Anytime it's odd, we're going to go through the x-axis. So that's going to help us to graph this problem. So what I want to do now is I want to put these x-intercepts on our graph so we don't forget about them. We got -5, we've got 5, we've got 3, and we're going to use these when we go to put all the pieces together to make this graph. Next up, we want to look at the y-intercept. Now, the y-intercept, in a lot of ways, is the easiest thing to do. It means we're just going to plug in 0 for all the x's. So when we do that, we're going to get negative. And then we're going to get 0 minus 3, which is just -3. We're going to get 0 plus 5, which is just +5. And that's raised to the third. And then we're going to get 0 minus 5, which is just -5. And again, all I'm doing is plugging 0 in for this x, and this x. From here, we go to compute this answer. We're going to end up with a negative. We're going to end up with a 9. We're going to end up with a 125, and then we're going to end up with a -5. So that means 2 negatives. Our result is going to be positive. And when we multiply these these values together, what we're going to get is a value of 5,625. So 5625. And that's what's going to go on the y-axis. The next thing we want to look at is the end behavior for our graph. Now, we've already kind of set us up for this. We know that this function is going to behave like a -x to the sixth. So when we talk about the end behavior, we know we know that when we talk about the end behavior that even-powered functions behave one way and odd-powered functions behave another. We've got an x to the sixth to start with. And x to the sixth start up, end up, and have kind of that flattened U shape. But in our problem, we actually have a -x to the sixth. So that means we're going to turn this guy upside down, and we're actually going to start down this direction, and we're going to end down in that direction. That's our end behavior. The last piece of the puzzle now is to find our number line and find out where are we above and below. I'm labeling our zeros. And what we're going to do now is we're going to go back and we're going to plug in numbers from each interval. So if I choose a large negative number from this expression over here, and this is 0. So let's say I choose negative 10. Come back and keep track of the negative signs. Okay, so we're going to keep track of the negatives. So I'm plugging negative 10 into this expression up here. I've already got one negative guaranteed because of the one in front. So that's always going to be negative. Now, this guy right here is always going to be positive. So let me just highlight that right now and just say, this is always going to be positive because it's got the square on it. So we know this one's always positive. We know this one's always negative. So that's going to be true for every value we plug in. So now we really just have to focus on the last two. So plugging in a value here like negative 10 put in here is going to be negative cubed. So that will be a negative for this one. And negative 10 put into here is going to be another negative value. So we're going to have 1, 2, 3 negative factors. That's going to make this region negative. Okay, so now we're going to go through, we're going to do it again. Keep in mind, the first two factors are always going to be negative positive. So now I'm going to try the next two factors again, but this time I'm going to plug in a value between negative 5 and 3. And to be honest, we're going to cheat a little bit. We found the y-intercept. We already know that when we plug in 0, we're going to get out this positive value. So we know that middle region is positive. So now I'm going to jump to this next region. I'm plugging in a 4. Again, these two factors are always going to stay the same. When we plug in a 4, this one right here is going to be 4 plus 5 cubed. That's going to be positive. When we plug in a 4 in this last one, we're going to get 4 minus 5. That's going to be negative. So two negatives means we're going to end up with a positive value. Now, if you think about that, that makes sense. We were told the multiplicity of 3 was 2. That means we're going to get a bounce on the x-axis. So what that means is our function is going to be above the axis, it's going to come down, and it's going to bounce back up. So we can predict that from the multiplicity. The last region we want is a value greater than 5. When we go to plug that in, remember our first two factors stay the same. Now we're greater than 5. That's going to make this factor a positive. And when I cube it, it's going to stay positive. And if I'm greater than 5, this factor will be positive as well. Overall, we're going to have a negative here. So now we can go and we can start to make this graph. We know we've got to come from this direction and hit to that negative 5. So let's connect those. Then we know that we've got to leave the negative 5 and get to this y-intercept. We don't know if it's still going up or if it's already going up and it's starting to come back down. We don't know where that turning point is. So I'm just going to predict it's before the intercept. Okay, now there's no way of knowing. If you graphed it after, you're still okay. Okay, because we need calculus to do that. Pre-calculus tools won't help us there. And now once I leave that, I've got to make a beeline to that x-intercept right here. But keep in mind, we're going to have a bounce because of the multiplicity. So this is going to come down and bounce at the 3. And now I'm above the axis still. But eventually I've got to get back to that x-intercept at 5 and then go below the axis the rest of the way. So my graph is going to turn here and head back down. So this is what our rough graph will look like. When we're done, we can look at the turning points and see where the graph changed direction. There's a turning point here. There is a turning point at 3 in this case, and there's a turning point there. So those are the 3 turning points. So this is pretty much the best graph I can make from the hand by using the information we've gotten. I have used my graphing program to go take a look at this. We can take a look and see how close we were. And what you're going to find is that we've got the x-intercept of negative 5, of 3, and of 5 as we predicted. Our y-intercept is up here at 5,625. And you can see our turning point here came before the axis. Again, you would not have been responsible. You could have predicted it came after, but it's before here. So there are other 2 turning points there. So I hope you guys have gotten something out of watching us go through these last 2 polynomial graphs. You're required to be able to do these steps on your own. If you have any questions at all, please feel free to reach out to me. I'm always there to help you if you need it. Have a great day, everybody. Take care.